Welcome back. In this video we'll start explaining what classification is and give a brief introduction of what the process of classification entails. Now, classification is a data mining task of predicting the value of a categorical variable, sometimes it's called a target or a class. So here we have some input data, we have some data sets with instances, one or more data sets with instances, i.e. with columns, different columns and different values, and then we want to predict a categorical variable, i.e. a class. Now this is done by building a model based on one or more numerical or categorical variables. So our variables can be numerical or categorical, and we can use one or more of them, or maybe none of them, as you will see, to build that model. These variables or these descriptors, sometimes they're known as predictors, sometimes they're known as descriptors or attributes or features. They all mean the same thing. Now, one thing I'd like you to remember always, and as you will see from my videos, that sometimes I give you examples, for example, with data which only contains variables of categorical type. If you want to apply the same algorithm and you have data which contains numerical variables, then you can transform numerical to categorical, and you can transform categorical to numerical, so other way around. If you don't know how to do this, then please watch my data exploration and analysis tutorial. In there I explain these concepts: binning or discretization to transform from numerical to categorical, and I explain encoding or continuization to transform from categorical to numerical. Just to give an example, this is a data set, well known, the weather data set. We have four features or four descriptors, four predictors: outlook, temperature, humidity, windy, and you can note that all of them are of type categorical. And here we have our class, which is now play golf, either yes or no, and notice again it's actually a categorical variable. And this tree diagram here just shows us that the yellow box here is the class, so we're trying to decide whether to play or not to play based on values from our attributes or from our features or from our predictors. Now, one thing I'd like you to be familiar with is the linear non-linear separability, and please always remember to use diagrams. Diagrams help us greatly to visualize things so we can have a feel of what the data looks like and how we can go about our data. Now let's assume, for example, that we take some measurements from people randomly. We measure, for example, height and weight, and let's assume that we plot height and weight against each other in this 2D diagram. As you can see here, let's assume that weight is the y-axis and height is the x-axis, and let's assume that the red dots here are males and the blue dots are females. Now you can see that we can nicely draw a straight line that perfectly separates the two categories or the two classes. This data set or this data is said to be linearly separable. If there's overlap and we can't draw a straight line to perfectly split the data, then that's known as non-linearly separable data. Now you notice here we have only two classes, let's say maybe male or female. Sometimes we can have more than two classes, and we can transform that into a binary classification problem. By the way, I will be only focusing on binary classification, so the class would be yes or no, maybe positive, negative, true or false, 0, 1, or -1, +1, or something like that. If we have a problem with multiple classes, then we can transform it into a binary problem by, for example, using the one against all technique or any other technique. Again, to show you a non-linearly separable data, here we can't actually draw a straight line to perfectly separate the two classes, but there are some other tricks where we can transform the data now from the dimension we have now. That we have now two-dimensional data, let's say weight and height, only two dimensions. We can add more dimensions so we can split that data. By the way, if the data is two-dimensional, i.e. we only have two measurements or two attributes or two features, then we can draw a line. If the data is three-dimensional, then we can draw a plane. if the data is more than three-dimensional, it becomes a hyperplane. And the good thing is that anything you can do in 2D, if you can draw a line in 2D, then you should be able to draw a plane in 3D or a hyperplane in more than 3D. We won't go into much detail for the math behind it, but you can trust that can be done. Now, the upcoming videos for classification we will be covering these classifiers: 0R, 1R, naive Bayes, and decision tree, which are based on frequency table. We'll be covering linear discriminant analysis and logistic regression, which is based on covariance matrix. We'll be covering the k-nearest neighbor classifier, which is based on similarity functions, and we'll be covering artificial neural networks and support vector machines. What else? Just remember always to use diagrams. Remember this concept of linear separability and non-linear separability. The problem of binary classification when we have only two classes. If we have multi-classes, then we can transform it into a binary classification using the one versus all concept. And always remember that if your algorithm applies to categorical variables or categorical attributes, then we can transform them into and we have numerical data, then we can transform them using encoding, and the opposite is always true. I will stop here. In the next video I'll be introducing the 0R classifier. Thanks for watching, and I'll see you next time.